All right, and it's recording. So welcome everybody. Tonight is the 30th of, it's not the 30th of March. It's now the 6th of April. Somehow times just fly by, don't they? But we're here with the Dallas Personal Robotics Group Robot Builders Night Virtual. So we're still getting out with COVID, hanging on as it is. We'll go around the table like we usually do and share project progress in the last week on robots and whatever other related targets, and throw questions out to the crowd. We also have, just as a reminder, coming up on Saturday, we'll have a guest presenter, Jesse Brockman from, I think he's in Colorado. Spark Fun Ambassador is going to, by popular demand, he's going to give a review of his J-Bot, one of his outdoor rovers, and kind of some construction things related to it, sensors, hardware, software. So we have that coming up on this Saturday. And unless anyone else has something else from a big picture perspective, then I think we'll jump in, and sounds like we've prearranged. So we'll start off with Doug, and then Chris, then Ted, and then Carl, and then whoever else after that. So Doug, take it away. What's going on?
Well, I've done a little bit more with my VNC robot. I'm going to put this information in the chat real quick, and then I'm going to share my screen and show that for the people that don't necessarily have access to the chat. And let me see. Coming over here. So you should see a Word document on my screen, which basically has the same information that I just put in the chat. And it has to do with the using VNC to control your robot remotely, which we're planning on doing with our telepresence robot. It's very simple. You sign up for a VNC account. It's free. You can control 5 robots for each email address that you sign up with. I don't think it's fair to sign up with a whole bunch of addresses just to control a bunch of robots, and it actually can control any computer of any kind, basically, not just a robot. VNC is built into the Raspberry Pi as a client, and the VNC viewer, which it shows here how to download, is what you actually use to go over to control the other robots. You create a login with the VNC viewer, then you use that same login on the VNC client, and they just know how to talk to each other. And I'm going to demonstrate that. Oh, wait. This is the VNC viewer, and you put in what your robots are so that they know how to connect to each other. And then I've actually connected to one of them over here, and I'm hoping you can see that on the screen. I've built this front end, which nothing's wired up yet because I don't have a robot to actually run. But I used Tkinter to create all these buttons and everything on here. And I've got some tabs so that I've got different types of things that I'm doing here. I can move the robot. I can pan the camera. These little X's around the side are meant to be feedback from the robot about distance sensor information, such as I'm driving along and I'm finding something is 10 centimeters up there. It's letting me know. This is the camera, which I was busy trying to position. It's not logged into anything, so it's just upside down. There I am, maybe. Yes, that's me. So anyway, that's all my good progress is that I've started building my Tkinter front end. It's real simple to wire these button clicks up to calling a serial function that will send information over to the Arduino or whatever is actually controlling the movement. And my intention is to use those. I'm going to stop sharing here, unless somebody's got questions they want to ask about that.
It looks like your what you put in the chat got cut off. It got cut off after download from down. Was there something else there?
It's 1, 2, 3. Let me check the chat.
Got to step 2.
Step 3 should be on there, so I'll make sure it gets all in there.
Okay.
And right now, I'm not done with this front end because my intention is to put these two together, and right now they're two different apps. But I wasn't able to get the video working inside the Tkinter frame in the time I had. I know it's possible. I've seen it done by the guy over at Apply Image Search, who's actually supplied me the code for this other video. So I know it works. I just didn't get it all wired together yet.
So I have a question.
Yes.
So just so I understand the concept here. So how would this work if multiple people want to access this? We would all be sharing an account?
Right. If multiple people wanted to access the same computer, their VNC viewer would have to be logged into the same email address.
And I'm not necessarily asking for at the same time. I mean, that's another question, but even just...
It's actually not at the same time. It's back to what you were related to. To control that computer, which would be the robot in this case, the robot is listening on my email address. So the VNC viewer is on my email address. It's okay to have multiple VNC viewers on my email address, all either working at different times or the same times. My intention with the telepresence robot is to not use my email address, but to use something like DPRG guest 1 at dprg.com or whatever they have for an email address. And then DPRG can have control of that one address and provide it out to the members who might need to get in. Does that make sense?
Yeah, okay. So that, I think, answers that. Now, the other thing I was thinking, to make that concept, to increase even the performance, I guess you could pick a resolution on the Pi that's much lower than what you are using here right now, right? Because in the end,
Probably.
I mean, for this concept, all you care about is seeing the video and seeing the control panel, right? And so you could probably tailor the resolution to sort of that, so that, you know, you're really minimizing any unnecessary communication. Now, if portions of the screen are not changing, VNC is smart enough to not, you know, consume bandwidth for that, I'm pretty sure. But you know, you could probably squeeze a little bit of performance out of it by just making the resolution smaller. You know, I mean, I use VNC a lot, and I find sometimes I have to tell it, you know, go at the lowest quality setting. So if I want real snappy response on the UI, I deliberately lower the quality setting on VNC to a point where it just looks totally crappy, but I get, you know, I get pretty near real-time response on my local Wi-Fi network. So I guess you could play with all that. Okay.
Yeah, I think you're right. And this particular setup that I'm using, I didn't try to customize any of that. And I believe that I'm going through the internet, not just on my own network for this particular example. And I was getting like a half a second to a quarter of a second delay on the camera feed from the client computer to my VNC viewer. And that's assuming that VNC didn't say, oh, look, let's go on his own network because we're there. I didn't actually.
Well, you could just run Wireshark, even on the Pi or on your computer. You could see where is traffic going to and coming from. I mean, that'd be one way to kind of be sure that it's not all just local LAN sort of traffic. So that's something you could do.
Yeah. So I'm going to stop sharing for right now. Give somebody else control of the screen.
Have you ever tried, so again, back to multiple people accessing this, has anybody tried, so what'll happen how many people can connect to a Pi at the same time?
Well, I
Because
did.
you could try it yourself from multiple viewing devices that you might have around the house, right?
Right. I tried that with 2 computers at my office that I'm sitting in, connecting to the Pi. So that tested to show that multiple computers could access the Pi at the same time.
Right, 2. So you have confirmation for 2.
What's that?
So you have confirmation for 2 at a time.
Yes. Of course,
Using
if you do more than one person per robot, you may have some issues with wanting to drive it at the same time. My thoughts is that the club will have several members that will create robots, and we'll have several members that are remote, and we'll kind of assign one to each. We may end up having to assign multiple people to each.
Okay.
So do you have a link to the full instructions that you could stick in the chat? Or?
Yeah, I'm going to go ahead and put those instructions in the chat, and I can also email them to anybody. It's just a Word document that I put together. Talking and not paying attention. Let's see. Step 1. Yeah. Let me do that real quick while we're talking. I get these nice little Windows 10 notifications out of the way. Let's see.
Yeah, you know, kind of like you said, the Raspberry Pi, Raspbian, whatever it's called, Raspberry Pi OS or whatever, has VNC built in, a VNC server, apparently. I loaded it on VNC on Viewer on my phone and tried to access the Raspberry Pi that way, but I actually had my wife loaded on her phone, which is, you know, separate from mine because our phones are individual hotspots and we can't do port forwarding or anything like that. So anyway, she couldn't access it. So I guess I did something wrong. And I was just going to wait for Doug to tell me what that was.
Well, there's a.
It didn't copy these links in the chat, so I'm working on getting that to be nice.
I think when you do it, really, like when I did it, and I've done it a number of times, on every Pi that I want to be accessible from anywhere, I log into the, I guess it's the server side on the Pi, and I log in with my cloud account to Real VNC. And then wherever the client is, whether it's my phone or my laptop or other laptop or whatever, I log into the same cloud account, my same Real VNC cloud account.
Oh yeah.
And then from that, when I forget this exact steps, but when you define the robots in the palette of options of robots, there is a way to specify the, like I can get at the same robot from either the local LAN IP or from the or across the network from anywhere.
Yeah.
And,
so Ray,
and that
did you
should work,
do
with your two phones.
Yeah, that's what I thought. So
no, Ray, did you do it on the local Wi-Fi or did you try to get to it from different devices over the internet?
I had the that's probably what I did wrong. The Raspberry Pi was, you know, using the Wi-Fi hotspot, so it was connected that way. And I know I can get out because I can look at websites and stuff. I did not do what Carl said though, log into the VNC cloud account. So that's probably what I was doing wrong. So I'll give that a shot and see. I had VNC Viewer on this phone, I don't know, several years now, but didn't have the account set up. So I could do things locally without any issue, but it was all, you know, this is my Wi-Fi hotspot. So
yeah, I mean, I was just asking because I mean, I haven't, only last week is when I signed up for the account. I haven't used the actual cloud-based stuff much, but even locally on Wi-Fi, the one thing I have noticed is that when I try to get to my target devices by name, VNC Viewer just sometimes doesn't find it. Or, I mean, there seems to be sometimes a glitch in the name resolution, right? I mean, if I often connect to some other computer in the house through VNC, and sometimes my viewer doesn't find that computer by name. I seem to be having more luck if I know that the actual IP address of that computer that I'm trying to connect to. So that's just some pattern I've seen.
okay.
Yeah, what I did is I had to be on the Pi with my cloud account. I think that's what Carl said. And
Right.
it then notifies the VNC server, here I am. And so
Yeah.
then when I go in the viewer, I say, add that computer to my deal. It knows how to do that.
Yeah. Yeah. That's probably what I did wrong.
So this is how it looks
It's
when
like
it's
the same thing.
configured. The way I'm talking about. So like this is both of these links open up the same my same robot, and you see under the properties, this one has a VNC server at that address, and it's got a signature MAC address and everything. And then this one is the directory lookup. I forget quite how I got there, but basically, you know, I can click on the local one. I think I turned it on. Yeah, there it is. And here it is on my network. So you can see its IP address is the 157. Or I can close that down and I can do it this way. And then I think it goes across the network. And it says VNC server is currently not looking for. So I've got something wrong. Oh, there it is. No, I don't. It worked. So here, I've got in by, that's across the network by this way.
Yeah. Did the IP address change? Is it different?
No, it's the same.
Oh,
It's
it
the
is.
same IP address, but it found it by directory lookup.
Well,
Yeah.
it doesn't need the IP address. The way when you go through the cloud, the IP address is irrelevant because
Yeah.
if you're going
Yeah.
going out in both, you know, the way the traffic is getting routed, the IP address of the Pi is 100% irrelevant.
Yep. Okay.
So, oh yeah,
Anyway.
it shows the connectivity. Whereas if this one, oh look at that. Here's a verification. Here I've opened up the same VNC to the same computer on two different windows, so I can open up that shell here, and it shows up on the other screen.
Mm-hmm.
To Doug's point.
Yep.
And to Chris's question, can we do it a third time? No, I guess not. Not that way. Okay,
Well,
anyhow.
You had two icons and you clicked on both the icons.
Yeah, I would need a third icon, I guess. And I forget how to add.
Computer. For instance, if I had changed my passwords to some, not my secret password stuff, I could have given it to you guys and you could have gotten in also, but I didn't get around to that yet. I'll do that at some point in the future.
Sure.
Say, here's my cheapo password. People can get in and look at it, and then I'll put it back to my real passwords.
Yeah. Cool.
And it won't work for you anymore.
Yes. All right. Hey, moving along.
So that's it for me. Oh, wait.
Cool.
I didn't know.
Wait, there's more.
But yeah.
Only just a quick sideline for people that like RealSense cameras. Right.
Great. Yeah.
I happened to notice this on the screen using two Raspberry Pis to create a RealSense camera. Some sort of crowd supply thing. I only just glanced at it. I thought of you. I made a mental note. It looks kind of expensive at $200. I don't know what a Pi is going for these days. Not a Pi, but a real. That just seemed like a lot. So I'm going to put that link in the chat.
Okay.
Anybody that's interested can look at it. I thought it was interesting but pricey. Now I'm done.
I don't think there's RealSense are that much cheaper either, and I don't know what they cost, but $200 is probably what you end up.
Yeah, 230 something or 240 something. Pretty close.
And this one, do you know if this one's built under the hood with basically Raspberry Pi kind of technology, or it just happens to use Raspberry Pi cameras?
It looked like, I just glanced at it, but it looked like it had Pi technology underneath and had the two Pi cameras in there. I don't know. I only just glanced at it. Okay. I thought about showing it to Ray, so I saved it on one of my tabs.
Yeah.
Huh. Cool. All right. Nice find. All right, so next in line, Mr. Chris, what you been up to?
All right, let me move the camera. Sorry for the motion. So on my Romy platform, let me see if I can. As I mentioned, I've been just not a lot of progress, so this will be quick. So I've been fiddling with the ultrasonic sensors, the cheap ones. I finally wired them up. You can see the blue and the orange wire. That's the echo signal coming back, or in sort of single wire mode. So I finally managed to get it actually wired up. Right now, they are facing more sideways. If you can see that. So they're facing sideways, but they are designed to be adjustable here. So what I probably want to do is have another one forward looking and two sideways looking, or maybe I'll make both of these forward looking. I don't know yet. I can fiddle with it, which is really what I want to get to. But what you see here, this ugly cable sticking out in the front, is what I need to get rid of, because the ultrasonics are going to my black pill on top, that's a green pill, and they're going into USB there on that. So that's my virtual serial link. Now, I mentioned that before. The problem with that idea of using the USB and virtual serial is that you how to deal with these bulky USB cables and connections, and so I have to. Here's one thing I sort of plan on doing. I kind of mentioned that maybe already. Where is it? Okay. Here is a connector that'll go into the Pi. Okay. And I just soldered a 100 mil spacing female header to it. Okay. And just so I have ultra low footprint, stuff going on down in the Pi, because as you can see, where all these USB connections are coming out, that's kind of where the third ultrasonic sensor wants to be, right? Very much in the front of the robot. So I can't, even if I go with like these right angle cables, I have a couple, right? And if I put you one of these cables or do something with it, right, I'm gonna have a lot less bulk going on, but it's still more bulk than I can afford if I actually want to utilize the space in front for another sensor, right? I really can't afford much bulk in terms of USB connectors there. So I'm just going to have to go, with one of these going in here. And then I'm just hoping that because of the short cables, I'll be just fine, with the USB signals going just through regular hookup cable here. Now, as I was fiddling with this, unfortunately, I made the magic smoke come out of my green pill because I got the polarity. So, the green pill is getting power through USB, right? So one of these pins is ground, the other power. I was feeding that into my green pill, and I had measured what's plus and what's minus, okay, and then hooked it up accordingly. Nothing worked. I smelled something, disconnected. Did it, and oddly enough, things were still working when I went back in with the USB. Things were still working, but I could smell stuff. Okay, so then again, connected it, was still not working, and something was getting hot. I couldn't see the actual smoke, but my laptop kept complaining. I was actually connecting it to the laptop at that time that I was overloading the USB. Okay, so there's kind of something funky going on, and then I realized what has happened. Okay, because again, I thought I had measured exactly where plus and minuses, and it's the two pins on the outside. One is ground, one is 5 volts, okay? And two in the middle are the USB data pins. So I had measured, okay, which one's which. Now, can someone spot the mistake I made?
Oh, yes. Yeah.
So, okay, I measured, okay, 5 volts, great. And I have that polarity on the meter reverse for stupid reasons. And so I'm, that pissed me off. So luckily I have 2 of these green pills because they came in a pair of 2. And it's just more, more soldering now. I have to solder a bunch of pins to my other green pill. So it kind of ticked me off, and then I just didn't want to do anything else now. So that's where I'm at. Still have to finish wiring this up. Well, again, it's wired up, but actually I'm pumping the data across once it's actually connected in a less bulky fashion. So that's all really.
Okay, everybody better check their leaders, their leads on their meters. I just looked at mine. Mine's right. So
AC/DC,
yep.
it's the red wire, it's the black wire, it's the red.
All relative. Yeah.
We feel for you, Chris.
And the white wires.
All I can say is you're in good company, because a couple startups ago, we sold this trailer tracking solution, and basically it was a little module that had a cell phone and a GPS tracker, and it had two wires, red and white. And we sell this, and all I had to do was to take the right and bolt the white wire to the trailer, to the chassis, and the red wire to +12. 50-50 chance of getting it right. 50-50 times people would blow them up.
Ooh.
And that's why Valolu has a reverse polarity on all their boards.
Probably. Yeah.
Something about having robust designs. Yeah.
Yeah. And it was weird because my laptop kept complaining. Again, I was supplying the USB. It was connected to the laptop in this case, not the Pi. And then the laptop kept complaining that my mouse is drawing too much current. Like, what does that have to do with my mouse? It's on a completely different USB host port. It's not even on the hub that I'm going through. And like, it's just real weird stuff until it dawned on me. I mean, clearly I'm drawing too much current. It just wasn't obvious why. Yeah, well.
That's gung-ho to hook stuff like this directly up to your laptop's USB. I decided a couple years ago that I would never do that because of what could happen to the laptop. So
I was going through a hub. So my mouse was going straight into the laptop. This thing was going into a hub, which went into the laptop.
That's good. So you got the sacrificial hub. That's the important part.
Yeah, exactly. Dirt cheap hub. I got one. In fact, I got one of these hubs. It's not working out as well as I was hoping it would. Oh, well, guess I shouldn't unplug my hub when I'm on video. So
that's a little hard to see, but we can hear it.
If when that comes back, what I wanted to show is it's one of those hubs that has. Why is the video not coming back?
Drivers.
It's one of those hubs that has on-off buttons for every
port.
For every port.
Really? I must have got the cheap one. It doesn't have any switches.
It's weird now. I mean, Google Meet is confused because even if I switch to the other camera, it won't show my video. Anyway, so it has on-off buttons, which I thought was going to be really useful because, so much I do with USB, and sometimes it's nice to be able to just shut a device off and shut it back on. But I think it's just switching the power side of things. I have seen situations where if the device I'm connecting to has power through other means, and I still have my USB connection intact, right? Where what I really wanted is press that button and completely, disconnect, that USB device from my computer. But that particular dirt cheap switching USB hub is not working exactly in that fashion. It's just, it does cut the power off to the device, but not the data lines. And so the computer still thinks, oh, it's connected, right? If the device is still powered through some other means. Yeah. But it seemed like a useful thing. I just need to get a better one because, again, I do so much with USB. It's like my desk is always full of USB cables. And so, it's a clever thing to be able to turn this on and off if it works.
Nice.
Well, I guess you should consider yourself lucky, right? Blue pill, maybe a couple bucks. blowing a USB port on a computer, boy, I don't know. That's got to be more expensive by a couple
Yeah.
orders of
No,
magnitude.
no, you're right. But those USB ports on the computer, I mean, they have self-resetting fuses, right? So if you draw too much current, which in this case I wasn't feeding in, super high electrostatic discharge or anything, right? I was just drawing way too much current because of the incorrect polarity. So
Yeah.
the USB ports are supposed to be protected from that.
Yep.
Yeah, I have an old laptop I use, and I've shorted the USB ports on that many times, and it still keeps going. So pretty good.
Timex, huh? Takes a licking and keeps on ticking.
That's cool. I just know I got one of the, you remember some 8 years ago or 7 years ago, they started to come up with the 200 or 300 megahertz power adapters for laptops using the gallium arsenide power supplies, really high frequency switchers. So they were super small and compact. So I got one off a Kickstarter, waited a couple years, it was late. And when it came in, I took it to the office and I plugged it in and I plugged it into my laptop and the screen went blank on the laptop. So I blamed the motherboard frying in my laptop on that thing. And I got the Kickstarter people to pay for a new motherboard, actually. Wow. Although they claimed there was no way that it could have caused it. But that's my little lesson on if the manufacturer has a power system where the supply is designed for the motherboard, I'm sticking with it. And then I noticed later on that Lenovo, for a while there in their one system dashboard app, it actually detected and displayed the power supply capacity of the power supply. So you could get the 45 watt for the little computers or the 90 watt or the 135 watt. You'd plug them in and it would know how much power was available. And then they decided, no, we can't have people having that much visibility, so they got rid of it. But it knows it somehow. It's figured it out.
I got a question for Chris. Those
Sure.
ultrasonic sensors, are they, you've tried them out, and do you get like short returns from the ground from them being so close ever, depending on what surface you're on?
So that is certainly one of the things I'm worried about, and it's why I wanted to get to just a point where I can try things out. And so far the answer is no. And but I mostly or really, my house is free of carpets. I only got hardwood floors and hard floors, right? And so my use case is such that I'm not going to have stuff on the ground, at least not right now for what I'm just doing, fiddling with stuff. So at a later point, if and when this gets turned into a contest robot, let's say for another round of firefighting, and they obviously had to skip last year. This year, I haven't heard anything. It would be next week, literally, if they had it. So if and when I decide to turn this into another actually, contest-worthy robot, then it could be a little bit more of a concern. You're absolutely right. But right now, it's all flat surface. I have not seen any issue, and I'm more hoping, and I'm more disappointed that it's not picking up things like, chair legs more easily, right? I mean, we talked about the cheap sensors, so that's what I'm worried about right now. More like stuff that's easy to miss with other means. That's where I want the wide angle of the sonar, but now it's not. I haven't gotten any false readings in my very, very brief test before I fried my black pill.
All right, cool, thanks.
So Ted, how's it going at your school? Any VNC challenges or misplaced red and black wires or?
Who are you?
Oh, go ahead. What's up? What's up in your your bench?
Oh yeah. Okay, gotcha. So I'm thinking about doing the outdoor contest robot, and so I pulled out my old AVC bot here, and just did some little tests on it on grass because we had some nice weather last week. It's snowing today, but anyway, turns out it wasn't really made for going in grass. It was more for asphalt and hard packed dirt. So so now I'm looking at options for something a little bigger, and because it'll make it through grass, but not very far and not in a controlled manner. So I'm kind of thinking like a skid steering robot. So I started researching motors and stuff, and bigger wheels. Anyway, so yeah, I thought I'd show you guys my old AVC bot here, and so it's got a LiDAR sensor on a. Let's see, I can't see what I'm showing you right now. I'm going to bring it up here so I can see what I'm showing you. Let's see. Let's do this. Right there. There we go. So I've got a LiDAR sensor on a servo, so it could kind of scan in front of it. And at one point I had a GPS on it over here, but I took that off because it really just the accuracy I needed for the AVC, the GPS wasn't doing me any good. It was just complicating things. So yeah, a lot of this is like I collaborated with Jesse Brockman, so we used a lot of the same hardware and techniques. He built a much bigger robot. I took the opposite approach and built something small. So yeah, let's see. So I'm working on some sort of skid steering robot. So yeah, hopefully I'll have a little bit of a design for that next week, because that's all I had to show right now.
So is that a crash guard on your LiDAR there, the blue?
Yeah, so I 3D printed this. It's flexible filament. I also 3D printed these holders for the bumper because, well, I did a lot of crashing into things and I got tired of replacing parts of the front wheels and the front steering mechanism.
Yeah, those LiDARs are like $150 now, so that's probably a good investment, right?
Yeah, exactly. So, and also, I kind of thought this helped with keeping some of the direct sunlight out of it.
Oh yeah.
Because sometimes when it got pointed into the sun, it had issues.
Oh, okay. Yeah, that's a good idea.
And this is the LiDAR light that's just kind of a single beam. Is that what it is?
Yeah, that's what it is.
Yep.
And it has pretty good range outdoors. It'll go, I don't know, 30 or 40 feet, which is really more than I needed.
Yeah, the test that I did on it, of course I wasn't looking into the sun or anything, but if I had to guess, maybe 100 feet or so. But
Wow.
yeah, I think it's good for like 40 meters.
Wow.
Yeah,
Yeah.
it might be. I never really tested it that far.
Yep. So I figure
And out in that, when you get out into the tens of meters, what's the resolution?
It is less. I can't remember. It was in the less than an inch range though.
Yeah. Okay. Well.
Yeah. And it's I don't know. I think the beam, I don't think it diverges very much. It's a pretty tight spot.
Right.
Of course, like some of the whatever the short range ones, you get quite a bit of divergence on the.
That worked okay in sunlight?
Yeah.
It's supposed to, yeah. Yep.
Yeah, I really didn't have any problems with sunlight.
Yeah. Yeah, I tried it out on my property, but I think it was probably in the afternoon. The sun was kind of behind it, so it was shining light on the walls that I was looking at. They were brick walls, and it got a pretty accurate reading off them. So it's not like it was a, very reflective, flat surface. It was very irregular. So, but yeah, I was impressed with it.
Ted, I posted a link to a skid steer I came across on our robotics newsletter this week.
Oh, okay, cool.
The guy built it himself and he used some Traxxas parts.
Okay. Actually, I might have seen that one. That was what was it, Afternoon Engineer or something?
I forget. I come on a weekly robotics newsletter I subscribe to.
Okay. Yeah, I was actually looking at, I just opened it up. I was actually looking at that video a couple days ago.
Seemed to go pretty good. I don't know if it'll clear any high objects, but it seemed to go good through grass and snow and dirt.
Yeah.
Wow.
Yeah, so the only issue I had with that one is he was using some custom machined parts, and I'd rather not have to go down that road.
Yeah, he had there was one shaft I think he had custom made.
Yeah. Yeah, I was thinking just some planetary gear motors and direct drive them to some wheels.
Well, cool. So outdoors. So this is good. We're getting some progress amongst the club on outdoory things. Very nice.
Those look like bicycle motors in there.
Okay. So next week, Ted, you have some more plans to show or something, maybe?
Yeah, I think so. I'll try.
All right. Cool. Well, I think at this point, then I'm going to try and yeah, that should work. I'll show what I've got this week. So we're going mobile, and I guess everyone can see. So you've seen this one before. I call this the Hover Sim. It's got some new stuff this week. It's acquired this NeoPixel ring so that I can keep track of heading, and I've wired it up so that once it boots, now the colors don't come across very well, I guess, but the blue is always indicating where the robot forward is, and the red where the robot backwards is. We'll come back to that in a minute. And then the white is where world or compass north is. So I did a little experimenting. There's the BNO 055. I did some experimenting on different fusion modes, and I have some thoughts and findings on that. Right now, it's using the fusion mode with all 9 degrees of freedom. Before, I was only using the gyro and accelerometer, so those 6 degrees. Is this coming across? Can everybody see it okay?
Yeah, the LEDs you can't really see, but
no, okay, have to figure that out. All right, so one of the things that we tend to do as a measure of where your robot is the Foursquare, and I don't have any cones set up, but I wanted to show you when you run this robot in Foursquare, what might it look like? And well, I think I also mentioned last week I tried to get spin mode working, but again, trigonometry wasn't working for me on the weekend, so I didn't have it last week. But so I upped the game. So this week now, not only do I have spin mode working, but I have Foursquare going. So let's just jump to the chase here, and let's do a Foursquare run. Now, I would argue that this is how Foursquare should go. How's that looking?
That's pretty nice.
And this is just
I love it.
Yeah, I was really pleased. And it kind of returns. It's got some offsets. It's only doing timed loops, timed runs, so a second per step, 20 steps, and it's using a PID loop on each motor and then a PID loop for the heading. So I got 4 velocity loops on the motors and 1 heading loop, but it's pretty repeatable, and it works pretty well even on other surfaces.
I like how the LED ring is right at the center of rotation.
It's pretty close, you know, as far as duct tape will let me get, or gaffer's tape. So that's the
Nicely
one.
done.
Oh, go ahead.
Nicely done.
Oh, thank you. Yeah. And then there's some other things that come along. I'll take it back to the table. Pardon the jiggling while we maneuver. And I'll show you some other bits related to this. And this
Dave,
is the build-up.
You don't have like a 5-year-old video of one of your robots doing that or something?
A what?
No, I was asking David Anderson if he had like a 5-year-old video of, you know, his computer or his robot doing that, you know.
Carl, do you have wheel encoders on the wheels?
Yeah. They are. Let me stop the loop. Yeah, it's got the magneto. It's got 2 Hall effect sensors on each one.
Yeah, okay, I see it there.
2 Hall effect sensors, and then this thing came off of Alibaba. It's got a metal chassis, and for $100, it was a metal chassis, 4 wheels, 4 motors, and 4 cables, which is nice. And then another like $40 got you. No, another $20 got you this Arduino Mega card. That it's really a nice card. It's got the motor drivers and then breakout pins for all of the stuff, and it made it pretty nice to wire up, and not that expensive. So what I was hoping to show, and I don't think the exposure gods are going to let me get away with this, but you'll see that. Let me get this out of the way. Whoops. Second time I drive off the table. Oh yeah, so you'll notice here that this is interesting. What I've done is I've wired up these LED. The first 3 LEDs are related to the IMU calibration status. So the leftmost one, which is currently super bright red, is the fusion calibration status. Then the next one is gyroscope, and the next one's accelerometer. So gyroscope. So this shows that the accelerometer is at a 1, so it's yellow, so it's out of calibration. The gyroscope's in calibration, and I noticed that if you just reorient it like that, it'll catch up on the calibration, and that's not happening now. But we'll just reset it because. But I noticed that with the magnetometer that there's a couple of really strange things. So at first I was trying the 6 degree of freedom, and you can see that I had this set up where I can, like right now, this angle with the blue tape is 137 degree heading. And I noticed that in the other mode, the fusion mode that was just gyroscope and accelerometer, no magnetometer, if I would just spin it like crazy, after about a minute or two, so 25 revolutions or more, it would be off. Its estimate of this direction would have changed by like 30 degrees. And I haven't recalibrated it now with this fusion mode that includes the magnetometer, but I think it's a lot more stable. But of course, the magnetometer does. It's pretty sensitive, so you'll see that the calibration goes out when you get metal nearby, and it also changes the heading, or at least it has at other times. I've tried this. But
I suppose you could have been spinning fast enough to saturate the gyros or something.
Yeah, it's really interesting to, but I don't. I mean, it's. I guess we could calculate, because this thing is it something like 300 degrees a second, and I don't think it can accelerate quite that quickly. So it'll be interesting to try and figure out what's going on there.
Mm-hmm.
The other thing I was going to demo though is this spin mode. So The spin mode, how do I get there? So I'll do it the spin 0 mode first. So see, when I did that, this yellow light came on. And what happens now is that it's locking the robot orientation always to be this way. So no matter how I turn the robot, the virtual orientation is always this way. So now if I move it this way or this way, right, it's with respect to the robot facing that way. Get it?
Mm-hmm.
So no matter how I rotate it, left is always left and right is always right. And that's critical to the asteroids mode that I'm working on, because in asteroids mode, I'll have it wired to where there's like a virtual thruster. So you get it going in a certain direction, and then unless you add friction, it just keeps going until you turn it around and give it thrust in the other direction, just like the old asteroids game. So for that to work, it had to know this. It had to be able to do this kind of thing, where it could always go left to right, even though it's rotating like crazy. And that's what was able to do the 4 square and spin around, but drive in a straight line, even though it's spinning. So it makes you wonder, what is a straight line when that's going on?
So, but to the earlier point that was made about saturating the gyro, I guess, maybe, I mean, it's something you do want to look at, right? Because I remember from the gyro that's on the Romy controller, you have to configure it, right? And you have to say, all right, I care about my max rotational speed is going to be 400 degrees per second, let's say. And, probably you don't exceed that under normal circumstances, but it's a little faster than 1 rotation per second, right? So I don't know what the spec is of the BNO 055 that you have and how fast you were rotating, but it's not just about acceleration, it's about how fast are you turning and are you exceeding how the gyro is configured.
But
I think because it has different ranges, you mean? Or sensitivities, I guess.
It does have different sensitivities, but and if you look in the sheet in this sensor, you can set it to different ranges in the individual mode, but in the fusion mode, it automatically does auto ranging for you.
Okay.
But the way I was thinking about it, the way I understood it, this thing is a gyroscope. It's not measuring rotation per se. It's measuring changes in the rate of rotation.
Right.
Right. It's measuring changes in the rate of rotation. So the theory that I had was that when it doesn't have the magnetometer as a reference, it definitely has some kind of motion thing, so that because it tries to take out 0, right? So it's going to have a high pass filter. Basically, it's going to have a high pass so that it only allows detection of motion, so that whenever I have it turning at a constant rate, whatever that rate is, once you reach that rate, it thinks right now that it should be feeding out a 0, right? Because it's not, the rate of change of rotation is not changing. So then I was thinking that it comes down to, okay, so how accurately does it, when it makes this transition from not moving to turning, how accurately does it measure that? Because that's basically a step function that the longer you sit and turn, it's basically integrating the error in its estimate of the new speed. So I haven't figured out how to get rid of that, how to sort that out yet, but here you can see where the magnetometer is lost. So the fusion calibration is 3. Fusion is 0. That's the red one. Gyroscope and accelerometer are both calibrated, which means the magnetometer went out. So if I do this, usually, the magnetometer comes and the whole thing comes back in. And so far, I've been pretty pleased when I've been piddling around last day or two that it comes back to the same measurement pretty consistently.
Yeah, that was a question I had. The okay, like when you held your cell phone next to it, probably it's the neodymium magnet in there that is very powerful and screws the thing up. But I wonder if you can sense, like saturations or going way off scale. And then that that's an external event that's not associated with the magnetic field of the Earth. Maybe you could do that for the motors. Just say if this is out of range or all over the place, then
With,
it's some outside influence.
with the BNO 55, a lot of that information you lose when you're using the fusion modes. It takes care of that for you and doesn't give it to you.
Yeah. Hmm.
So there's a lot of learning and calibrating to do still, but it's kind of cool. It's working remarkably well. I'm pleased with it so far.
So you have fusion mode with all three now.
Yeah, this is 9 degree of freedom fusion mode.
Yeah.
Yep.
Well, Carl, you know how your phone is messing up the magnetometer.
Yeah.
You also have motors there that have coils in them with electricity flowing through them.
Oh, I understand. Yeah. No, I get it.
That'll do the same thing as holding your phone over. The little table you're sitting on, does it have metal legs or metal supports underneath?
Well, it has some screws, but it's cheap Office Depot. And of course, there's these super highly shielded lines, right? So I'm with you on that. Dave, the only thing I've noticed is that the offset doesn't seem to change with speed, at least the time I tried it. So it seemed to be more related to time.
Well, when it crashes, when it's rotating in place, or maybe I'm confused. Is that what we saw earlier? That you lost the sync on the magnetometer?
Oh, well, the calibration got lost, but strangely enough, it still had a good measure of the heading, even then. So, like, if we just rotate like crazy, and just let that go for a while. See, okay, getting dizzy yet?
Yeah, he's going to make your robot throw up or something.
What I was suggesting is that the reason that the magnetometer crashes when you're spinning is the same reason as it crashes when you hold your phone over it, which is that magnetic fields generated by the motors are crashing it.
I don't disagree with you. I don't doubt it. The thing I find interesting though is, and I hadn't tried this till now, in 9DOF mode, you'll see even when it's going out of calibration, the heading is not changing. And when I was in some of the other modes, like when it's just magnetometer and accelerometer, when I would do this, it would shift the heading reading. That would distort the heading reading. So and from reading on the literature on the BNO 55, I think it's actually able with sensor fusion, it's actually able to tell, since there's no information rate of change from the gyroscope
or the accelerometer, probably,
or the accelerometer, then it can throw out the data. It knows that it's the magnetometer that it can throw out and hold the heading. So
one interesting thing I found with my BNO 55 is that if I were to leave it just sitting on a table for a long time, the heading wouldn't change at all. It wouldn't drift. But if I moved it around, then, and it didn't take very much moving, just the slow amount of moving, the heading would drift from the gyros. So I think they were doing something with the accelerometers, and they were just had some sort of software that was saying, well, it's not moving, so the heading can't change.
That's what I mean. It's a high pass filter. So it's because the whole problem with gyros is taking out the zero, that is taking out the bias in the gyroscope, right?
Right.
So they must be doing some fancy stuff in there to take out that bias. And but it's been rock solid every time I've tried it in various places around the house here. So
Yeah. Carl, by bias, do you mean drift?
yeah,
Okay.
but so like where it's not moving, but the gyro is reporting as if it started to turn.
Well, bias and drift are related, but it's not the same, right? Bias is like it's giving you a non-zero reading, even though you're not moving. But then over time, that right, you can calibrate. So when I use the gyro, the low-level one, the raw gyro on the Romy, what I had to do is you sit still for a second, you look at what it's telling you while it's in zero motion, and that's kind of a steady state offset. That's the bias that you have to then remove. But then over time, that number becomes invalid because of drift.
Right. Yeah. It'll change.
Right.
I found that value is very temperature sensitive.
Oh, yeah. Yeah. So maybe it's 10 degrees then, you've got temperature in there with, the other 9 degrees.
Yeah, there's so many factors, but at the moment I'm just tickled pink because I think you could say it was doing pretty good just with motor velocity and heading control loops. So as soon as I can work optical flow in and get some other kind of position loop that's not based on the motors and the wheels, it could have a lot of fun with this little guy.
You're talking about temperature. I mean, one thing I realized on the Romy control platform, even though when so I'm now pretty sure I'm going to end up using just the B&O that's sitting on top here, but a while ago I reported getting pretty good results with what's built into the Romy controller, which you can't see. It's kind of okay. It's down here somewhere. That's the Romy control board down here. I was getting pretty good results with that. Now the Pi is on top here, and actually I've elevated it a little bit for wiring reasons. But my point is, the gyro that's on here is pretty close to the heat source of the Raspberry Pi's processor, right, which has a heat sink on it. And so again, I'm actually surprised that I got decent results, but again, I haven't really looked at it over a long time period. But now knowing more about these things, I'm pretty sure I don't want to go the route of using that thing that's built onto that circuit board because it's exposed to the heat of the Pi, and yeah, that's gonna change. So, not a good idea.
Maybe like, ovenized oscillators, we have to stick an oven on our BNO 055s or something. Keep it maintain that constant temperature,
Always hotter than ambient, so you can at least have it the same temperature, right?
Right, yeah. So
I do believe they have a temperature compensation built in, so they measure the temperature.
Oh, they do.
Yeah. You would expect them to, but
what doesn't it do?
It does.
Okay, so correct me if I'm wrong. I was thinking that even with Dave's ultra expensive IMU, that kind of the recommendation was not to include the magnetometer. But Carl, now you're saying you can do that, and it's working reasonably well. So what changed?
Yeah, well, I mean, I think I don't know. I think the jury's still out, but I think what's changed is that I don't know that from before. I don't know that I was looking at all the factors I should have been looking at. So in the last week since we last met, I did I mention trigonometry problems on the weekend? So
Yep.
I got into the weekdays when trigonometry starts to work correctly, and there was some noticeable code cleanup. And then there's just, I mean, to David's point, it's hard to get away from just spending time observing what happens and trying things in different situations. And I haven't gone through that yet to really compare the different modes. So I tried magnetometer plus accelerometer. I tried gyroscope plus accelerometer. I tried, at one point I tried closing the heading loop based on the fusion of magnetometer and accelerometer. It was terrible. It was such a noisy reading. It was absolutely terrible. The magnetometer plus accelerometer, but this fusion mode, it's been rock solid. And I think, I have to measure it, but I think it's been better than gyroscope plus accelerometer. I think it's doing better with the 3 than it is with the 2. The thing that really surprised me most though was, because with that turntable, right, or I would sit and spin it, and I noticed I noticed this when I first tried the things like the Foursquare or the out and back, it seemed to be getting askew. And I figured that there was 2 contributing factors to the skew. And one was that when the robot's rotating, so what I would do is I would rotate the command for the motors based on the offset of the current rotation of the robot. But because the measure of the current rotation of the robot was old, it was constantly veering off to one side. So what I did, so that was one factor. So what I did was that I just measured it. I drove it at a couple different spin rates for 12 feet, and I measured how far off it was. So I got a fudge factor that seems to be more or less constant with spin rate. And so now that offset factor basically gives a lead on the thrust angle depending on how fast the thing is turning. And that's how it's able to drive straight instead of off at a goofy angle. But even with that, okay, and even with that, either way, without that, what I noticed was that if I did the same motion over time, it would start to gradually do this this thing, and that because I measure I measure the absolute orientation with respect to the Earth, and all the calculations are done with the initial measurement and the current measurement. And the only thing that could account for that, I mean, the angle could be accounted for by the thrust angle, but that would be the same for every run. If I'm going back and forth over many times, the only thing that could be changing is that offset, the original estimate of where the Earth north is must be changing.
Wheel slip.
Your analysis of where that is. I want to comment on something Ray said. When we were talking about excluding the magnetometers, that was specifically an indoor, not an outdoor, because at least in my experience, I've used that a lot outdoors and it works remarkably well. But Carl, to your question, and maybe this is a redundant stuff you already know, but a 9-axis magnetometer, there's a Kalman filter in there that's putting all those axes together and giving you back a single vector. And if you think about what those axes are doing, you've got 3 gyroscopes, one on each axis. So for the gyroscopes that are oriented toward the Earth, as they drift around, you can use the accelerometer to tell you to correct that drift. So 2 of your gyroscopes, you can correct their drift with the accelerometer. Now the accelerometer is also sensitive to the movement of the robot chassis, as Einstein taught us, and you can't tell the difference between that and gravity. But over a long-term average, the accelerometer does give a pretty good idea of where down is or where up is. Okay, so now we've corrected those 2 gyroscopes, but what about the Z-axis gyroscope that's drifting around? You can't use the accelerometers to zero it. They don't give you the proper information. So how do you keep them from drifting? This is after you've compensated for, the offset and all that stuff. Basically, you have this long-running integration, and it's just of its nature, it's going to drift. So the magnetometer is there basically to correct the drift of the Z-axis gyro, because once again, you can't really trust it on short term the way you can trust the gyroscope to tell you, exactly what's happening. But if you average it over a long haul, its estimation of where north is correct. So you can use that to correct the drift of the gyroscope. So basically, think about what you have is 3-axis gyroscopes, and then ways to correct the drift of those gyroscopes. Accelerometers for the horizontal axes, and the magnetometer for the vertical. Now, I've seen JBot drive along, say, outdoors and pass something like a big car that will deflect the magnetometer. So if you're just looking at the magnetometer in that point, you do get a deflection. But as was pointed out earlier, the gyroscopes know that you haven't turned, that the body hasn't turned, and the Kalman filter sorts all that out to give you back. Essentially, the way to think about it is that you're getting high frequency information, as you say, high pass filtering from the gyroscopes, and you're getting low pass filtered information from the magnetometer and from the accelerometers.
Yeah, that's what I think I've seen, and you phrased it so well. So what I hope to do for next week is maybe I can get some data that compares the 6-axis mode to the 9-axis mode, and maybe show an example of how and verify the extent to which the 9-axis mode takes out the gyro drift. Because I don't think many of the club robots move around by constantly rotating like this one. But I guess this one, anyhow, when you're constantly rotating, things behave a little differently. Maybe I'm finding some modes you guys haven't stumbled on much before, or dug into.
Well, I have to say that I have been able on RCAT to do that with just a gyroscope, without
your triangle you showed.
And I can have it spin in place for long periods of time and not drift more than a fraction of a degree. Basically, just using the rate gyro and integrating it. Okay, here's the difference. What I had when I first stuck the gyro on the robot is I already had well-calibrated odometry. So I had something that I could measure the gyroscope against and adjust the gains until they matched exactly. It was actually interesting to see where I couldn't get them to match because the gyroscope can catch little movements of the platform that the odometry doesn't catch.
That's differential odometry? Differential? Oh, is that differential odometry?
I think so.
Yes, I'm sorry, yes.
Well, that's another thing, though, David, because I think what you're saying is that you managed to do a good job of calibrating your gyroscopes. You had a good reference with the odometry. And the only calibration I have on this IMU is what I did in January, 1,200 miles ago, just callously just wiggling in the air until I got everything calibrated, and then I just stored it. I haven't dabbled with that at all yet. So it could be that if I spent more time and did a more careful calibration, maybe it would have less drift.
Well, let me give you a simple example. It's been real annoying to me. On the JBot robot, when it was first set up, you've probably seen videos where I go off through the woods for 500 feet and come back and hit the mark exactly where I started. And it worked great, and I was so pleased with it. So then years later, we decided we were going to look for orange traffic cones, and I had to add a camera to it. And that camera has a pan tilt axis servos that are all the way down at the bottom of the mast where the IMU is mounted. Nonetheless, as I close in on a target, I begin sweeping back and forth looking for that target, and that throws off the magnetometer. And that's, I'd say, at least it's on the order of 1.5 feet away from the IMU.
Hey, Carl, were you saying that you were thinking your gyros were measuring the rotation of the Earth?
No.
Oh, okay.
No, I was poorly saying that they're measuring rate of changes in their own rotation.
They're called rate gyros.
Yeah.
Well, Carl, I look forward to seeing your asteroids mode. I just can't figure out how you're going to do the torus wraparound trick.
The torus wraparound trick. Oh yeah, that.
You know, if it goes off
Yeah.
the screen to the right, it reappears on the left.
That's when it turns into this blue police box, and we. Yeah.
Yeah.
That's where you need.
That's going to be impressive.
You need 4 identical robots.
That could work too. Yeah, I figured the closest I could get to that, Kareem, would be the would be the other version of asteroids where it bounces off the walls. Right. So
I don't think I ever saw that one.
really?
Yeah, you can do a virtual bounce.
Yeah.
Sort of like the breakout or something like that.
Yeah. But for now, I'll be happy to get the asteroids mode behind me so I can work on some house chores and the outdoor robot. Okay, well, I've commandeered too much time, so I'll shut up now. But that was my progress for the week. So
That's great progress.
thanks for all the feedback. All right.
Putting the rest of us to shame, Carl.
Say what? No.
You're putting the rest of us to shame.
It was a good week.
Yeah.
We all have our good weeks and our bad weeks. So
Yeah, I have a quick question to share. It's a good time. I was using this, I'll share my screen. I was using this Wixel, and my question is about this antenna direction. So I realize if I put the two, this is the wireless, I use it as the wireless link as a serial communication. If I have it in separate rooms, I find, so basically my computer has this part and the robot has another part like this, right? So what's my orientation for this? Like, I mean, do I lay it flat? I mean, if you look at my screen, this is, I think this is the antenna. So I find if I just lay it on the side of my computer, it doesn't communicate well. But if I raise it up, it helps. But I mean, I think there's an orientation, like it's a fan, it goes to a certain direction. So anyways, does anybody have any recommendation? How how would I orientate this?
I know, like dipoles, it's like a donut, that shape. But if you get into more directional antennas, they actually have like main lobe and side lobes. And
yeah, like my Wi-Fi antenna, I heard it's like a flat plane in the room, right? So
yeah,
what is this orientation?
who knows?
Okay. All right. Yeah, okay. Maybe, I mean, it's okay. I'll just keep it in the line of sight. It works if it's in the line of sight.
what about empirical tests? Can you just?
Yeah, I
try
find if
different
I raise it
orientations
up, it helps. But yeah, it's just really empirical. Maybe it's higher, the better. I don't know. It's not a big deal. I mean, it's not going to limit my robot as long as it's wireless. So cool. Yeah, that's my main question. Not much progress else. Pretty busy on the rest of the work, but yeah.
John, is there a ground plane associated with that little edged antenna?
Ground plane? There is a ground wire. Oh, I see what you mean. Is there a plane inside this chip?
Well, often with a variety of antennas, the ground plane needs to be beneath the radiating element. So that might control what orientation it's mounted in.
I see.
I might Google Wixel mounted on robot.
I tried that. There's yeah, not something like telling me how to orientate it. Yeah. Okay.
Oh, here. There's a Bing image of the Wixel beam pattern.
Really?
Oh, there is.
Well,
Really?
I don't know. Yeah. Here.
Wixel
I'll put it into the chat.
Can
There
you can you present it?
Yeah, go ahead, Carl.
Oh, sure. As the newly dubbed expert on Wixel beam patterns, here we go. At least on screen share. So take your pick, whichever one you want to look at, but this one looks colorful.
And that one's for a Wixel?
Angry Moose lighting. No, maybe not.
I want one that's 3D.
Yeah.
Maybe there's something else out there called a Wixel.
It could be.
I think you're gonna have to throw in Pololu as a keyword.
All right.
Yeah. The antennas like this are very directional, and they have like a very large main lobe and very small side lobes, kind of like that one in red there. That one would look more like this, but I mean the patch antennas, they have their own radiation patterns, and like for cell phones. And
these antenna look like the ESP chips. I think is this similar thing? All these antenna on the chip. I mean, not on the chip, but on the small board. Though these look similar to me. Just a few wiggly lines.
yeah, they look very similar to the ones for Wi-Fi.
Yeah, I mean, I imagine it's perpendicular to this, right? The direction. I mean, I don't know. I'm thinking it's got.
It's a patch antenna for.
Oh, you have a external antenna. Is that what you mean?
But no, the ESP32 cam. It's got a little printed circuit board antenna like that.
Yeah.
Or even probably the D1 minis have something similar. If I can find mine.
Yeah, I mean, I used the Bluetooth ones in the past. They have a similar wire trace PCB, and I think I've always mounted it sort of sticking up,
yeah,
a little bit away from the rest of the electronics.
Mm-hmm.
Yeah.
That's the Wemos D. I think that's the D1. Yeah, and it's got a little.
So imagine the distance is perpendicular to the line pattern, right? It's like on the side.
Yeah.
I think that makes sense.
But the reality is none of that should matter unless you're really trying to sort of to push your luck on the range, right? I mean, what range do you hope to get out of it?
Yeah, inside my house is okay, and probably within my side
you're gonna have to narrow it down to inside your room, because I mean, I don't know the Wixel, but if it's got the amount of power of a Bluetooth module, you're pretty much down to your room and the one next to it, and beyond that, it's.
Okay. Yeah, probably operational wise, I should keep it in my site.
Yeah, I mean, you should do some tests really to make sure that this can meet your expectations, but these things perform a lot less well than you might think once you go outside of your room.
Okay. Cool. Yeah, I think that solves the problem. Not to
Apparently, it's a lot easier than finding somebody that knows antennas.
Yeah. Black magic.
Yeah. All right. Cool. So John's making progress. Who else? I think Pat, you mentioned you're already waiting on parts.
Yeah, I'm still waiting on drive parts for the robot. I got some timing belts in, but I'm still waiting on some 40-tooth timing sprockets.
Nice. Soon, hopefully.
Well,
once the migratory birds drop them off for you.
It's a long flight, eh? It's 2 weeks it's been flying now.
All right.
Just a quick one. Per recommendation from this group, I placed a DigiKey order, so I threw in a couple things. You can't see this probably, but this was recommended to me to deal with my I2C troubles. It's one of those I2C multiplexes, right? To have.
Yeah, that looks like it.
Yeah, I mean, you use it for different reasons. In my case, I would use it if I wanted to just have two devices on separate buses. So one device that's acting up, can't bring down the whole bus. So I bought me one of those. Haven't tried it yet. It'll come in handy at some point. And just again, because it's a pay for shipping anyway, I figured, let me throw in a couple of Raspberry Pi Picos, since there's a lot of buzz about it. I honestly don't think they bring anything to the table that the STM32 doesn't bring to the table. Absolutely not, right? But because it's Raspberry Pi stuff, there's going to be at some point a pretty big ecosystem behind it, right? And lots of examples that are that expect you to use this, and so it'll come in handy if I want to do something and just follow that example, down to the T. And then I figured it's handy to have one of these, right? Even if, again, it's frankly not even the same performance of an STM32F4, right? A Cortex M4 with the floating point hardware built in. Mm-hmm. You're better off than the Pico. So, but again, it's $4 a piece, and there'll be lots of examples, and it'll come in handy.
A lot to say for the $4 price,
Well, that'll help you check the orientation of your red and black lines. So,
yep, I'll let me see if I can smoke one of these. Exactly.
No.
Chris, on the I2C multiplexer, how do you control the multiplexer? Are there separate GPIO lines, or
no? So apparently, what you do is you send it a command, and I don't know if it's 1 byte or 2 bytes. Maybe just 1 byte. It has its own address. It is a device on the bus. Okay, so you send it one command. You basically tell it which downstream bus, of which there are, is it 7? Yeah. Which downstream bus you ultimately want to connect to, right? And then you just do your I2C transaction to that downstream device as if this thing wasn't even, there.
Okay.
Right? The way I think of it almost is it's like almost like a CMOS, a 4051 or 4066, one of those analog switch things, right? I mean, it's just some analog switching going on inside to connect one of the 7 or 8 downstream buses to your upstream bus. And yeah, you tell it to an I2C command. So no GPIO is getting tied up.
So initially you would use its address to tell it how to set up, and thereafter you don't talk to its address unless you want to change the setup.
Correct.
You just talk directly to the device.
Correct.
Cool.
Chris, can it change the address?
Go ahead, Pat.
Can it change the address on a downstream device? So some devices are non-addressable or non.
That's one of the use cases, right? So if you have 2 devices, you want 2 of the same thing, and you can't change its address. It's almost like plugging stuff into a USB hub, right? Is how I think of it. Now you plug your 2 displays, let's say, into two different downstream ports, and you just talk to one at a time, right? Every time you talk to one, though, right, you have to first tell the multiplexer, okay, now talk to bus number 1. Now you do the talking. Now talk to bus number 2. Now you do your transaction with, with whatever is connected to bus number 2. So people use it in cases where two devices have the same I2C address and you can't change it.
Or you get the device and it has a fixed address and you want to use two of them.
Yeah, that's what I really meant to say. Yes,
Yeah.
or you want devices to be isolated because if one acts up, it can't bring down the whole bus.
Which is a topic you're sensitive to right now.
Right.
All right, cool. What else is going on this week? Let's see.
Well, I can go if you want.
Oh, go ahead, Ray.
Okay, so I don't know if every other state has similar stuff here, but this is the registration renewal for my 65 truck, and once again, it's the case of loose nut on the wheel. This time it was the steering wheel. There's like one main nut that holds it on to the column, and then there's three other nuts that hold it's called a horn ring onto the steering wheel. So the last time I got it inspected, as I'm driving away from the place, the horn starts blowing by itself, and two of these bolts, two of the three bolts had worked their way out and pushed the horn so it was shorting to the column. So I hadn't driven the truck since the last time I got it inspected. Now I have to get it re-inspected, and so I had to fix the loose nut on the wheel problem, where the horn wasn't going off by itself, and the steering wheel was very loosely attached to the steering column. So had to basically find a drill and a tap, and I think they're called shoulder bolts. It actually has a flat area near the head of the bolt, and the rest of it's threaded, and had to make three of those, and tap out or drill and tap out the holes because they were basically just stripped. The bolts were just falling out. So so that was one problem. The other problem is that the speedometer cable broke, and I haven't even looked at what that is yet. So until I can get the speedometer cable working, it doesn't make any sense to go up and they won't pass it. So that's what I've been working on. Oh yeah, my wife decided that we needed gutters on the house, but before we could put up gutters, we had to repaint because it's been like 11 years since we painted last. So we were outside this morning wiping off, the surfaces to be painted and caulking, and no paint has been applied yet, but we're, that's what I've, it's the honeydew trap. I'm in it. So.
Oh well.
Anyway,
rough week for robots at Ray's place.
It has been. Yeah. No work has been done. So.
Well, maybe the robot guys will be with you next week.
I hope so. I hate to paint.
All righty. Well, let's see. Anyone else? Kareem? Oh, Kareem, were you going to mention the 17th call for help?
Well, Carl, I'd be happy to.
Just
because I know so many people are dying to spend another Saturday on Zoom. But seriously, the message was in the email. I would recommend this as an opportunity to give or feed forward to the younger kids who are trying to do what you guys are interested in, and they really need like the guidance and the insights from folks like you. So if you have an opportunity on the 17th to be a judge, I sent the link in the email, and all you got to do is register on that site and lose about 6 hours to robotics on Saturday morning. Maybe it's a little bit longer than that. I didn't actually compute it, but
I guess the good news is it's not driving across town this time.
yeah, that's right. So and no sneezy kids to get in front of.
Oh, there you go.
So and it's super easy, right? So in the Zoom they've done it backwards. So in years past, each panel, see, we basically put together 2 or 3 judges in a panel, and we like to have one robotics knowledgeable person in there, and maybe one business kind of knowledgeable person, and the hard part is getting the robotics knowledgeable people, because they're the ones who can judge the technical merits. But typically you'd send a panel in a room, and then the teams would rotate on through, and you'd do one after the other. This time the teams get put in a breakout room, and then the judge panel just goes visits each team that they're up against next. And there's more time available than in past years. In past years you had to basically wrap up right away. Now you've got 10 minutes of deliberation between each team. So the pace is a little bit slower. Anyhow, be happy to, and if anybody has questions about how it all works, you can tap me by email, and we can connect offline. Thank you for giving me the opportunity, Carl.
Absolutely.
Kareem, was that link I posted today of interest? The people here in Dallas with their robot motors.
So the one that you posted today was a different company. They weren't the Modus Labs. They seem to be out of British Columbia, maybe, or something like that. It looked like a Canadian address, but I think it was. I worry that it's a little bit of vaporware. It looked like all of the stuff, all of the materials were renderings and not actual real things. Sometimes it's harder to tell these days because the renderings are getting pretty good.
Yeah, I told you about my time traveling levitating robot, right?
Right. Exactly. Yeah, there's a lot of vaporware in the robotics industry, just like there is everywhere else, and so it does seem like they are demoing some interesting things, but as far as the gearbox that they're talking about, that just seemed like a very large hollow sun planetary stage, which is an interesting approach, but it's apparently pretty large, and so some people were complaining about that. And I have no idea on all of these. If they're targeting the industrial robotics industry, then these are really expensive things for high school teams and hobbyists, and probably don't really apply. But I'm always looking for possibilities.
We'll have
I
to
know
follow sun.
The first radio control gear that I had back in the 60s was made by a group in Chicago called Bonner. And the servos had a harmonic drive in them. And I'd never seen one before, but I learned about them because whenever you crashed, you had to go buy another one of those little thin belts and rebuild the thing. And, but I had never seen one since then. So I think that's what the Segway uses for their motor wheel combinations.
Do they?
And and zero backlash, which is a big thing if you're trying to balance.
Yeah, no, it looks very nice, and apparently the patents have all expired. So there are a couple of people places that manufacture them. You can get them on eBay for a couple $100. But that's a pretty steep price, and I don't think you see them in the size
You
the
should
kind
get
of motors
some
we're looking at.
You should get some to play with and evaluate, and then tell us what you learned.
Yes, sir.
There's some interesting homemade ones, 3D printed out there.
Yeah, I sent some links in about that, just some YouTube videos of people experimenting with that, and there's a lot of interesting.
Do they have a wave generator, or are they cycloidal?
I've seen both.
Oh, okay.
So there are links to people who are making both of those right now. And there's actually quite a bit of an activity, it seems, in the YouTube maker community around
So
that
are
right
they
now.
3D printing them or making them with metal or?
Yeah, 3D printing.
Oh, yeah. It seems like.
Yeah,
Like a
metal is a
whole.
lot tougher. But they're
Say that
using
again?
things like, they're using, commercial bearings and stuff like that.
Oh.
But otherwise, the custom parts tend to be 3D printed, and they tend to be a little bit on the large side too.
Yeah. So what is a hollow sun planetary? I've never heard of that.
Well, yeah, you have a sun gear in the middle of the planets, and then the
Right.
ring gear around it, right?
Yeah.
And what they did is they just enlarged the whole thing, put a lot more planets around it. So the planets are small compared to the sun in the center. And
Oh.
then they made a very large sun that is, maybe half the size of the ring gear. And then put a hole through that so that you could put wiring through, if you wanted to, because that seems to be a common thing in industrial robots. They want to send the wiring to the next stage through a slip ring in the hole of the joint.
Yeah. So the sun would have internal splines then or something?
No, the center open portion is just meant to be a pass through for wiring. It has no function whatsoever.
Oh. How do you drive it then?
That's a good question. Probably a belt drive or something like that.
Oh, okay. All right.
Or a motor that has a pass through on it. There are some of those too.
Yeah,
but
when
I think usually it's
a
slightly offset belt drive or something like that.
There was a salesperson that was really trying to push harmonic drives, but I really didn't have, they looked interesting, but I really didn't, I had no application for them. So I was just honest with them and I said, I really don't. I don't know.
Yeah, no, you gotta have an application for it. That's for sure.
Yeah. So many moons ago.
Well, I have a story for Ray. I gave away my car this morning. My wife bought a new car, and so I have her hand-me-down. And my old car had like 360,000 miles on it, and the Blue Book value was just a few shekels. So I gave it away. So before I could give it away, I had two tasks. I had to sign the title, which I did, and I had to remove the license plate, which was easy enough to take off 3 of the 4 screws, and the other one was rusted solid in place. So I got out my impact driver, and I pounded the shit out of that in the driveway this morning to no avail. So then I got out a cold chisel, and I tried to chisel the head, but this must have been the world's hardest rusty bolt. I could not chisel the head off. So then I got out my tin snips, and I cut the license plate off of the screw and sent it away to wherever good old used cars go.
Well, at least you didn't have to cut the bumper off to get the license.
I pass along time. So now imagine that if you were actually going to work on the car itself, multiply that times 1,000.
Oh yeah. Yeah, the 65. It's the only car I ever restored, and there are a lot of things that I could have done better. It looked great just after I restored it, but it was my only vehicle, and I was basically building the structures here, so it was the work truck, and it's it definitely was used as a work truck. It's the paint doesn't look as nearly as nice as it used to, and there's all these things that pop up that that was the only time I had a battery that actually exploded in that truck, and so. But I guess it's only worth something to me now. I probably couldn't. Well, I'd probably ask like 8,000 for it. but I don't know if anybody else would think it was worth 8,000 or not. But
how are you doing on the 360,000 mile scale?
that one only has let's see, it's got about 40,000 on it. But the other Toyota that it's actually my wife's car, it has 220,000 on it. We're hoping it'll go to 250, just because we bought a new set of tires for it, and by 250 they'll be worn out. So we want to get our money's worth out of those tires. So, but yeah, it's a great little car. It's a Toyota RAV4, 2005. I thought it was going to be totaled in Austin. We were in like a 4-car accident, and it was like $13,000 worth of damage, but they fixed it anyway. And yeah, it's definitely the Timex. It keeps on ticking. So
I have a question I would like to ask the gathered assembly, just a curiosity for me for things going forward, and that is on the robot, whatever robot you're working on now, what language and development environment are you using? And we can just go around. I'm in the upper right-hand corner, so I'll say I'm working in C and I use the GCC toolchain.
I don't know what corner I'm in, but I'm using Python on the Raspberry and C++ on the Arduino.
I'm doing the same as that.
I'm using ST Micro's tool suite.
So on the microcontrollers, I'm mostly using Platform IO these days as the IDE, or Visual Studio Code with Platform IO. And so that's mostly C and C++. And on the Raspberry Pi, of late, been more Python than anything else.
Similar. Arduino C++ with that platform IO. That's on the Arduino. On the PC side, I'll probably use C# for the UI or the automation.
So I'm using C or C++ with the Arduino, and Python for other stuff on the Pi. And then I really hope to be getting into JavaScript and Espruino based devices. So JavaScript just to be different. And then I use the Visual Studio Code for all of it as an editor or environment.
Espruino, is that like the ESP32s or?
No, it's some I guess really good C-based programmer in the UK did a port of what looks like Node.js for embedded devices. So if you can imagine Node.js, which normally runs it powers the servers for websites, right? Big things. But he's got a version of it that runs on 2032 button cells for little IoT sensors.
So it's JavaScript basically for microcontrollers, right?
Yeah, basically. And it's event driven, so it seems to be that he's done it so that it wakes up and runs tiny bits of code and then goes back to sleep. So it's really power efficient. So I'm interested to see how it does with these platforms, and because I think it could have a potential to give a nice low-level control and good tight interaction with timing, but still have a pretty high-level language and the benefits you can get from that.
Carl, can you put a link in the chat? Esperanto, yeah. It sounds like the computer version of Esperanto.
He calls it JavaScript for microcontrollers, and I think it's pretty much a one-man deal, but a bunch of places have ported it. It's got all kinds of hardware support, and what little I've dabbled with it, mostly hello world kind of stuff. It's been pretty well behaved, and I mean, it's very friendly to wireless interfaces, Bluetooth and Wi-Fi. So
Is
basically,
is JavaScript something electrical engineer likes? I heard, but I just don't understand.
No way.
It's a web design language, right? It's
You
front
know,
ends and back ends.
we had I mean, in one of my work, we purchased the equipment. It's more like FPGA on the lower level and JavaScript outside the FPGA. So, which was hard to maintain, but yeah. And then I heard like electrical engineers like JavaScript, but I don't know. I don't know much about it. I just heard this.
Well, look, there's my board down there, Nucleo F4011RE. Also 4046, but I don't see that one. But,
But the Nordic, I mean, there's some pretty decent little processors in here, and so anyhow, I've got samples of this stuff. Where's this shop? I got samples of I got a watch, I got all this stuff. I just need time to go mess with it.
Do you use JavaScript at work or have some background in it, or why would you want to use JavaScript?
I do. Let's say the developers that I manage use it at work, and the story goes that I got my degree in '85, right, and then I designed circuit cards, then I designed PowerPoints, and then comes along the 2012 time or 2015 time, and I came to DPRG. And I thought, okay, so what's happened with languages, computer languages, since 1985 when I graduated? So somewhere I have this mind map that starts with the basics, C and Fortran, whatever, and it kind of shows how they branched and tendrilled out. And at that time, I figured, okay, I can't learn all the languages, but how am I going to narrow it down? So, okay, I have this view. I still have this view of C that I learned in college in the 80s. Carnegie Mellon, somebody there was saying C was named after the grade that it deserved as a language. and that just, I shouldn't have that attitude, but every now and then even now I keep running into that stuff with these Arduinos where, the syntax works for a class, but it doesn't work for an object. Why the hell not? It should. So it just bugs the crap out of me. But so anyhow, so I figured, well, I'd try something new. And between that, it was either JavaScript or Python. And both had like modern web-based development options, more accessible. So I just picked JavaScript, and that was enough different. I wanted to do something different, and it was way different. So it took a long time to figure that out by self-paced whatever. But now I have a respect for it, and I can see it has warts and flaws just like C. So anyhow, 3 languages, why not? We're all learning, lifelong learners, right?
I heard JavaScript is hard to maintain because it's not strong typed. That do you guys agree?
Oh, okay. So that's why they have like.
Don't start a language war.
Yeah.
There's reasons for loosely typed languages, and there's reasons for strongly typed.
Thank you. Yeah.
Kareem, did you weigh in on the what environment you're working in right now for whatever you're doing robotically?
We're doing everything in Java on Android Studio because we're running everything on Android platforms.
I guess I could go. I'm primarily Arduino because of Arduino processors, but so Arduino processors, Arduino IDE. I'm hoping to switch to the ESP32, primarily because it has LoRa transceivers and Wi-Fi and Bluetooth, and there's just a lot of things you can do. And Python for OpenCV stuff on a Raspberry Pi. I've used some of the Teensies. I think the 3.1 was as far as I got. Never had a 3.2 or a 3.5 or 3.6.
Dave, when you say Arduino and the Arduino IDE, does that imply C++?
More C. I haven't really seen the need to use C++ that much in robotics. I mean, most of the things I can do, it seems like more straight, just.
I do know. I would have just said, instead of in robotics, I would have just said in my life.
In your life, okay, yeah. I guess I'd have to say that too, because I've never really found a good use for object orientation. Especially in robotics, it seems like it's way overkill, and I don't know. It's like the thing, about opinions. Everybody has one. The rest of that.
Well, I appreciate the feedback. That's interesting information to have.
So were you on the same existential path that Carl was on? You were looking at this tree of programming languages, and you're deciding which branch to take, or?
No, actually, I'm firmly fixed on the branch that I'm on.
Oh, okay.
I will say, when I studied music history, one of the things that jumps out is that for a long period, there were what were called common practices, which means that all the people making music were making it in about the same way. And then when you hit the 20th century, it suddenly becomes this multi-headed thing. And there's not really a common practice, and there really hasn't been for like 100 years. And for me, the development of computer languages and the development of musical languages have a lot in common just because of my background. And so I wonder if we're going through one of those multi-headed periods. For example, I've mentioned this before. In the field I work in, there's lots of scientific libraries that have been honed and tweaked and work real well, and they're almost all written in Fortran. That the scientists use that have been around for, since the last century. I don't know anybody that writes in Fortran, and if you look at a modern Fortran compiler like the GCC Fortran compiler, it's really just a front end. They generate a parse tree and then hand that off to what would be the C compiler. So it's not really a Fortran compiler at all. It's just a translator from Fortran into C, or kind of a halfway translator. But I have to wonder, if 100 years from now or 200 years from now, will we have zeroed in on common practice languages, or will it still be as multi-headed as it is now?
Fortran's actually experiencing a resurgence. It's back on the top 20 list. It hasn't been there for 10 years, and it's just back.
You see that? That was announced today in the news, wasn't it?
Yeah.
We'll talk about not strongly typed. I don't know if you guys have ever read through any crufty old Fortran code, but the programmers routinely did things like you can use the index of one array to actually access the array that's sitting next to it. As long as you know where they were in the common segment. And there's really no rules enforced.
Somehow it seems like there's a logic that says any rule is meant to be broken anyhow, but that gets back to your common practice, doesn't it? Right? Because the only way we survive in a lot of these languages is by having a practice that works consistently and sticking to it.
And I have made this observation before. It's again a musical analogy. A lot of robot building is switching from instrument to instrument without ever getting good at playing any one in particular. And really, to play one well, it takes years. It really does.
Is Fortran still used, or parts of it still used in Linux? Because when you like install one of the Raspberry Pi OSs, I could have sworn I saw some reference to Fortran zip by. I don't know if anybody else has ever noticed that, but I thought Fortran, what's that?
Maybe if you built yourself a scientific workstation, it might have included the compiler.
I don't know.
There's a lot of Fortran stuff out there, like from GNU, right? I mean, you can install it. I'm sure there are people out there who need to use it. So that's probably what you saw. You can install it along with 100 other language compilers.
Yeah.
In my college, I mean, in college years, the computation of fluid dynamics, some packages are in Fortran. So many code are written in Fortran. I think code won't really go away unless you. Yeah, I think it's hard to replace the code. So I think Fortran will, if someone uses Fortran before and the project goes down, it'll still be Fortran unless someone wants to rewrite it.
So you said dynamics?
A lot of the
fluid
is Fortran.
Yeah, banks and the government have that same trouble with COBOL. They can't get rid of it, and there isn't anybody working in it anymore.
Y2K.
So C++, I think if for performance, C++ is the way to go, right? I kind of treat Python like a glue that it takes everything, you can link everything together. What I see is high performance systems are usually in C++.
Yeah, I think Python is interpreted, and that slows it down.
Yeah, right. I mean, yeah.
And I believe that recently some of the Linux kernel is now in C++. That after having supported that long. I have to say my own journey was like upwards and back down. I actually came out of hardware and therefore assembly. And so when I first ran into a C compiler, it was one bulk. And then I climbed up operating like a lot of times at one company fourth kind of premonition in a program. It's all reverse Polish in top. It basically all this led me back down to C. And the things I do at work, I almost always write in scripts and shell scripts, and anything that doesn't run fast enough in shell scripts, I can go back and code in C. But that's less and less necessary with faster and faster machines.
How about a good old PL1?
There's a formula I think I should try to formalize that basically has to do with how long a scientist will wait for his results. So you simplify the problem. If it takes too long, well, I won't wait that long. I'm not going to wait 2 weeks to get my numbers back. Well, you simplify the problem, then you can get your numbers back in 3 days. So then you get a faster computer, then you can go ahead and put a head back on that spherical cow and start doing the longer calculation. So, but there's some point at which, you either need a faster machine or a simplified problem because people won't wait that long for their numbers. As I say, I haven't formalized this. I probably could publish it in some obscure journal.
I think there's a guy who wrote a book similar to that. Oh man, what was the name of it? But it surfaced in the PMP certification, the Project Managing Professional, and it's and somewhere the concept is that it's the duration of the prototyping cycle. So whenever you have when the cost of getting that first prototype is really high, so it's going to take weeks and weeks and months to get a prototype and answer from the prototype, you're going to spend a lot more. You're going to be a lot more comfortable spending time to get the design right, because it's going to take so long to build it and actually check for the answer. But now when you get these scripting languages, Python, JavaScript, whatever, and you can click it out and hit the button, and you see if it works in like microseconds. You know, it doesn't matter. You're not waiting for a board shop to turn your code in 2 weeks, or taking your cards, your stack of cards down the hallway, trying not to trip and throw them.
But you're saying we can be sloppier?
I think that's what's happened, honestly. I mean, it's the world of the perpetual beta, right? I mean, it doesn't really matter, because if it comes out and they have the little bug, as long as you don't die, it doesn't matter, because there'll be a patch for it in another 20 minutes. So
this is like an old carpenter carving out a chair by hand, putting all these little filigree and beautiful effects on it, because he's going to have to do it all by hand anyway. Yeah. There's no fast way to do it, so you might as well make it decorative. But if you can actually crank that out in just 15 minutes, you don't bother with the filigree.
Yeah, who cares? It's commodity. Throw it out. And I think that's in a way what's happened with languages, really, to your point, because at the end of the day, they all have their pros and cons, right? Some are easier to read than others to some people than others. Some of them are faster for this kind of runtime. Some of them are slower. Some of them are easier to maintain. Some of them are more inspectable by the DoD for security compliance. Some of them are more type accurate. Some of them are more robust for pacemakers. And hell, I mean, I really want to make sure that the pacemaker doesn't have a vulnerability. But that's just not as important for my phone or for the little Nintendo game, right? So I think in a way it just doesn't matter.
And their civilization fell.
You know, let anarchy ensue. I mean, there's a similar thing in my mind of the like in IoT. So 10 years ago or 15 years ago, there was this thought that IoT is going to be the next big business opportunity, because you have all these infinite number of devices capturing these infinite numbers of data points, and in big data, IoT generates the big data, and the money and the business opportunity is in the big data. And it kind of came around full circle. I was in this one embedded thing, and this guy from IBM Cloud Computing came by, and he stood up in a presentation. He said, you know, everyone thinks that the value is in big data is in having all these data points, but guess what? If you look at it the other way, as soon as you have a zillion sensors all measuring the same temperature, the value of knowing the temperature from that sensor, it tends towards zero. So the value of the big data is, it's a commodity. The data is a commodity because you can get the same data from everywhere. So I don't know where I'm going with that, but
I think that's spot on. When I first got involved with the seismologists, there was a lot, which is 30 years ago, there was a lot of concern about people cheating or spoofing the data records, either that there would be a nuclear shot and somebody would hide it, or that there would be something that someone could make look like a nuclear shot in order to harass their neighbors. But what's happened since then is, you know, back then there were just a few hundred seismic stations online around the world. Now there are tens of thousands. And the idea that you could spoof one, you'd have to spoof, you know, thousands of computers. The algorithms, if you're way outside of bounds, they just throw you away, you know. So it's not really a problem anymore. All that security and all the worry about them spoofing the data has kind of gone by the wayside, because there really isn't a practical way you could do it.
Nowhere to hide.
Yeah, there's too many data points out there.
Yeah.
Well, I think I'm going to call it quits.
All righty.
Must be that time.
Happy dreams, good language dreams, and all that kind of stuff. And we'll catch you on Saturday.
Later, guys.
All right. Bye-bye.
Bye now.